start a recording on it. Just okay, so I'll record this. So right, MATLAB assignment 3 deals with Markov chains, and you've already learned about Markov chains in section 4.9 in the textbook. And you know, they give some interesting information here. Okay, and for the first challenge you're going to have in these MATLAB exercises for MATLAB assignment number 3, these two exercises, is you have to set up the matrix. So in MATLAB assignment number 1, they talk about tossing a fair coin, and at any point in time we look at the outcome of the previous two tosses. Okay, and there are 4 possibilities. So you can see here the HH, HT, TH, TT. So HH would be getting a head followed by a head on the coin tosses. HT would be getting a head on a coin toss, and then it's followed by a tail to a coin toss. And then you have the states. You have the different states. So there are 4 states, and you're going to determine the probability in going from one state to another in one toss. Okay, so on that note, let me just write something down here. So let me go to the whiteboard here, and let me just hold on here. Okay, so there are 4 states: HH, HT, TH, and TT. States 1, 2, 3, and 4. And of course, we re-put the states down here. Okay. All right, and so I am recording this, and I will put the recording along with MATLAB assignment number 3. But how many entries are there to fill in for this 4x4 stochastic matrix? Good. 16 entries, right? 16 entries. And let's talk about the first entry here. So going from state HH to state HH. Okay, so you could have like for example, is it possible to go from state HH to state HH? Well, if H, I want to be careful here how I draw this. Okay, so if you got a head on your first toss, and then you got a head on your second toss, okay. Given that, one moment. One moment. Given that, what tosses would these two heads correspond to? What's this toss here, the first one? Well, you know, you're moving from one state to another state. So to move from one state to another state, you have to flip the coin again, right? You have to flip the coin again to move from one state to another state. So this H here would mean that you got a head on which toss? The second H, the third. That's right, Robin. Well, Binyam, here's the thing. Here's the thing. I understand why you said that, but we're only doing one coin toss to move from one state to another state. So the second H would mean a third toss, and the first H here would mean what toss? What's this first H go with? Well, you only flip the coin once. What would that state have to be? I shouldn't say state. The second. That's right, Noah. And I know this is a little bit, what they're doing is they're formulating a coin flipping experiment, and they want to write it as a Markov chain. So the first HH means that you went from the first toss was ahead, the second toss was ahead. And then you flip the coin and you go to state and you get a head on your third toss, but then the previous toss was the second toss. Right, it goes 1, 2, and then 2, 3. That's right, Benjamin. And then you'd go 2, 3 to what? 2, 3 to 3, 4, and then 3, 4 to 4, 5. That's right, Solomon. You got it. You got it. So that's how this first one works. Okay, and so we can go. Can we go from state HH to HH? Is that possible? Yeah, it is possible because the second toss here matches that there. And so with what probability do you go from an HH to an HH? With what probability? That's right, 50%. Good, Solomon. Good, Wastina. Okay, so that's 0.5. All right, are there any questions so far? All right, well, let me ask then. Can I go from state HH to state TH? Can I go from state HH to state TH? No, because the second toss doesn't match the second toss here. Right, that's right. The second toss is H, and so this is a no. So that means HH to TH, which would be this value here, what would we put there for the probability? Good, good. We put 0. And so this is how you're going to work the first problem. And then, you know, you can answer the remaining questions, but you have to get the stochastic matrix. You have to get the stochastic matrix. And, you know, so I got you started on that. Incidentally, what do the sums of the entries in the columns in all 4 columns have to add up to? Good, everybody. They have to add up to 1. Okay. Are there any questions on that guidance I've given you for the first problem? Okay. All right. All right. Well, then let me go ahead and now talk about the, you're welcome, Christy. You're welcome. Let's go ahead and talk about the second problem from MATLAB assignment number 3. Okay, and remember, MATLAB assignments 3 and 4, I may count them 60% of your MATLAB assignment grade, just because they're going to take longer time to do. MATLAB assignments 3 and 4. So I may do that. Okay. All right, Christy. Let's now go back to where was I here? Here we go. Okay. So now we're on the second problem with the bank teller. Okay. So bank teller, and this is something that you know, yeah, I mean, I think you all are old enough to know what a bank teller is. You know, a lot of you now, a lot of people, they just go to the ATM machine, right? How many of you go to the ATM machine to do your banking? You just to get money out, put money in. You know, sure, but sometimes that's right. Solomon has, Westina has, but there are some transactions that you. I hear you, James, on that. There are some transactions that you do need to see a teller for. Okay, there are definitely some transactions that you might need to see a teller for. And I'm not a bank expert, but maybe like a money order or something like that. Can anybody think of, okay, if you had to open your account, Christy says money orders. And what happens is it used to be this kind of, it used to be when you go to the bank, there were only tellers who were helping people. There weren't any machines, and there would be lines that form, and the lines would have like, you know, it's like a line at McDonald's or something. It would, you know, you would walk in the bank and there would be lines with multiple tellers, and the lines would be sometimes long. And this problem really relates to that, but you could relate it to, you know, like a line at McDonald's or a line at, you know, a Sam's Club, something like that. You know, I'm just saying, but we're working with the bank here. So this, you know, Costco has lines, right? Of course, there's self-checkout, right? But some people still use the lines. So when you read over this question, and I'm gonna let you kind of read this all over, but you're gonna let S sub I indicate the total number of people either in the queue, in the line, or being served as I. And there are states n plus 1. There are n plus 1 states S sub 0 to Sn. So if n equals 10, how many states are there going to be? Okay, how many states are there going to be? That's right, Solomon. There are going to be 11 states. 11 states. Okay, and so for this problem, Um, let me just go to the whiteboard then. Okay, for this problem number 2 here, you're going to have a big matrix. So state S sub 0 means what? What does state S sub 0 mean? How many people are in line for state S sub 0? Nobody's in line. That's right. That's right, Solomon. Now, can you go from nobody in line to a certain time, a little bit of time passes, and after that time, nobody's still in line? Is it possible? It is possible. So there's a number here. That's right, everybody. There's a decimal, a percentage here, right? S sub 1 means how many people are in line? One person's in line. Good. S sub 2 means 2 people are in line. Okay, and so you got this matrix here. And what's the most number of people that'll be in line in the queue? What's the most number of people that can be in line? Okay, but for this problem then, how many people? Good, 10. Because they say n is 10. Okay, so how many entries are there here? Well, what are the dimensions of the matrix? What are the dimensions of the matrix? Is it 10 by 10? Oh, it's 11 by 11. 11 by 11 matrix. Because there are 11 states. You can have between 0 and 10 people waiting in line in the queue at the bank. That's 11 states. So far, are there any questions? That, yes, Binyam, I mean, it is going to be an array. Sure, matrix is an array. And Binyam's seen this kind of thing in computer science. Now, the question is, so you're going to have a column. You're going to have a column with 11 entries, right? And you're going to have 11 of these columns, right? Now, the question is, what are the probabilities? Okay, what are the probabilities? Well, let me ask you this. Can the teller have nobody in line? And then like let's talk about this entry right here. Let's talk about this entry right here. Where you're going from, so like here, you're going from nobody being in line, and then suddenly, after a little bit of time, there are 10 people in line. Is this possible based on the reading in the problem for MATLAB assignment number 3, the second exercise? Okay, that's right, Solomon. This is not possible. This is not possible. Okay, you can't go from state 0 to state 10. You can't have no people in line at the teller, and then after a little time interval goes by, suddenly 10 people. Well, here's the reason why. If you look, well, but so some good comments here. What if they all came in at once? Well, but look at the conditions of the problem. I mean, yes, it could happen, but they're not allowing it to happen in our problem. Okay, so let's go to the reading here. Let's go to the reading. Okay, so far we're, okay, if we go to the reading, hold on here. It says here, in a unit of time, the teller will handle at most one customer, and at most one customer will attempt to join the queue. Okay, and then they're giving you some probabilities that this kind of thing could occur. But the point is, at most you would have one people. The teller may finish with the customer. The teller may not finish with the customer. But at most, one more customer could join the queue. So if the teller doesn't have anybody in line, okay, if you have here, if you have, let me see here. Let me go back to the whiteboard. Hold on here. Let me go back to the whiteboard. So if you're starting at state 0, the teller has nobody in line. Okay, then after a certain time interval, there could be nobody in line. If initially there's nobody in line, could there be one person in line? In other words, what I'm saying is we know that we can go from state 0 to state 0 with a certain probability. We know that, right? We know that. Okay, and you have to figure out what that probability is based on what's given in the problem. And this is where discussion among your group members can be helpful. Because, you know, you want to get the matrix right. If the matrix is wrong, your answers are going to be wrong. Okay, and you don't want that, right? Can you go from state 0 to state 1? Is that allowable in the problem? Absolutely. Okay. Can you go from state 0 to state 2? Can there be nobody can the teller have nobody in line, and then after a certain time interval, there are 2 people in line? Good, Solman. Good, Binyam. That's not allowed. Okay, that's not allowed. So this here is not allowed. So that means here, this entry is going to be 0. Okay. Now, are there any questions so far? Are there any questions so far? Just trying to, you know. All right. Well, yeah. So now my question is, what are these entries going to be? What are these entries here? They're all going to be zeros. Good. Good. Okay, so that's a 0, right? They're all going to be zeros all the way down. So you're going to have a big matrix to type into MATLAB, right? But you have to figure out what's that probability going to be? What's that probability going to be? And then you have the other columns. Okay, the other columns, all the way to state 10 here. Okay, so that's my guidance for you for MATLAB assignment number 3, the second exercise. How many found was this helpful? Okay, wonderful, wonderful. Thank you, everybody. Thank you. Are there any questions at all before we move on? Okay, then let me stop the recording on this here.